just going to do my own start recording. Okay, so hello everyone. Welcome to week 7 AOAD lesson on code engineering class diagrams. And actually, this topic is pretty simple. So I know we have a 3-hour session. It's unlikely to go to 3 hours. Okay, so I'll try to finish it in maybe an hour and a half, depending on how everything goes. Okay, so let's get started. So we're talking about code engineering of class diagrams. Okay, what we're going to do is we're going to recap what is a class diagram, and we're talking about transforming class diagrams into Java code. Those of you who are avid programmers, people who do a lot of programming, I think when you're doing OOAD and you're drawing class diagrams, at the back of your mind, you're already thinking, how do I transform all of these classes into code? And if I want to transform to Java code, I think you sort of have an idea of how that is going to be done. Okay, so in this lesson, we're actually going to do it. And you will see that it's actually almost as straightforward as you envision. Okay, so this topic really is pretty straightforward. Okay, now, next few slides is going to be somewhat boring. It's a quick recap of what is a class diagram. Okay, so the first thing, let's recap the class diagrams. Let me grab up my stylus. Woohoo, technology. Okay. Now, first thing we're going to talk about is the notation for a class in UML. Okay, and a class is basically is defined as a description of a set of objects with similar features, semantics, and constraints. OMG 2009. OMG stands for the Object Management Group. Okay, so essentially, if you take a look at this, right? I have my welcome tablet backwards. Okay, so if you take a look at this, right, it's a description of a set. This is a description of a set of objects. Okay, so a class, as you all recall, is a template, right? In that, whenever I want to create an object, the class describes what the object is going to contain. Okay, all of these objects will have similar features. Okay, semantics. Semantics basically means the ways that you describe it. Okay, so in this case, all clients are going to have a company address, a company email, and so on, and they also have similar constraints. Okay, so if a client must have exactly one employee handling him, right? Then all clients will have exactly one employee. Okay, pretty straightforward. Now, in addition, there are 3 compartments in the class notation. We have the class name, which gives the name, right? We have the attributes compartment, which gives all the attributes. In the previous lesson, in week 5, we talked about how you define attributes for UML. And then under here, we have all the operations. Okay, and in this case, client doesn't have any operations defined yet. Right? So this is a quick overview of what you already know about classes. Right? Okay. Next, I want to talk about an object, which is an instance of a class. And you may not know this, but UML also allows you to define an object. Okay. Now, the difference between an object and a class is very simple. We have the name. And if you look at the name, you have the name of the object. In this case, the name of this object is called food co. Then after the colon, it shows that food co is of type client. Right? So food co is an object of type client. And to define that it's an object, you underline the name. Underlining the name in the object name compartment shows that this item is an object, not a class. Are we alright? Okay. Right. Next is that for an object, right, under the attribute, you can define values for the attribute. Okay. So in this case, if you look at this compartment, the company address is given this string value, Evans Farm, Norfolk. Right? Company email is given this value, mail@foodco.com, and so on. Right? So that's the second difference between objects and classes in UML. For objects, you are allowed, you're allowed to define values for all of these attributes. Okay? Because every object has values for all of the attributes. Finally, please take note that instances do not have operations. Okay? Only classes have operations. Instances are nothing more than things that contain data. Okay, so you would never have operations defined for an object. On the other hand, if you look at the class, then what happens is that the class definition of that object will tell you what are the operations under that class, right? Pretty straightforward. Nothing really new other than the notation for objects. Any questions? Okay. When I ask any questions, if there are no questions, I'd appreciate it if someone you just type in the conversation, no, or just to make sure that I'm not talking to myself. Yay, Wexner, you're listening. Okay, so let's continue. Alright, this has already also been done in week 5 or week 6. Okay, class attributes, we know that they are part of the essential description of a class, meaning that if you are describing a class, you have to give me your attributes. Right? This is known as, whoops, Royston. Okay, so sorry, I'm going to add Royston back in. I think he got kicked out somehow. Let me see, Royston. Okay, Royston, you're back. Ian is still not around. Okay, Royston, can you hear me? Royston, can you hear me? If so, please type something in the conversation. All this being recorded, this thrilling TV. Royston, can you hear me? I'm going to have to assume, I'll just continue on with the lesson, alright? Okay, so what I was saying, yes. Okay, so class attributes, they're part of the essential description of a class, and also they give a common structure of what a class can know. What does this mean? A class contains data, right? And so all this data has to be contained inside the attributes. So in this sense, right, you can think of all the attributes as the things that a class can know, right? The knowledge that is contained inside a class. Okay. We know that every attribute has a type and a visibility, which was covered in the previous weeks, right? The type will define the format of the data, and the visibility defines the accessibility. So all of this has already been covered in previous weeks. I won't dwell on it too much, right? So I don't know why I'm showing you these slides, but they are here. Examples of class. We have a shape with attributes origin and color, with operations move and resize. Okay. We have your good friend the bank account class, right, with a private attribute account number, private attribute customer name. Okay. We have a public operation called get balance. It returns a value of type float, right, and takes in no parameters. Okay, as well as a set balance attribute. Right, so we've talked a lot about how to define classes in UML in week 5 and also review in week 6, so I won't stay on this for too long. Okay, so I shall continue. Now, let's get into the heart of the matter for this week. Okay, how do you transform a class into Java code? Okay, so if you take a look at this, we have a class called student, right? So since it says you have a class called student, we know in Java that to define a class, we say public class student. So this corresponds to this. Yes? Okay. We see that name is private. So we say that it is private. We see that name is a string. So we write down string. And the name of the attribute is name. So we do name. Okay? And that's how you define a name. And so on. It's actually very straightforward, very mechanical. So private int age, private date dob. Alright. For an operation, almost as simple. We see that we have a public operation, so we write down public. We see that it returns string, so we write down string. And the name of the operation is getName, so we write down getName. After we write down getName, we need to put in the code body. So we put open braces, close braces, and the code body is going to be in here somewhere. Once again, we do the same thing for the rest. For set name, there is a a parameter of type string called name, so we put in this part as well, right? Very, very straightforward. It's literally a one-to-one mapping in this case. Any issues? Okay, I'm sure all of you, when you were doing OOAD and creating classes, and you were writing all of this down, somewhere in your head you were thinking, okay, if I want to code this, this is how I'll code this. Right? All this week's lesson is talking about is confirming that, yeah, what you're thinking in your head is correct or not so correct. Okay, so this is what we're doing. Any questions at this point? Okay. I am concerned that Royston has not said anything. Royston, are you around? Ah, good. Royston is typing. Okay, very good. Okay, so no questions, pretty straightforward, right? We're almost done, sort of lah. Okay, there are other things that we have to mention. Now, how do we instantiate a class? This is just your OOP review. Okay, in order to instantiate a class, you would put in the class in Java, right? You would declare a class name, a class student, give it a name, right? And then its object, you use the new keyword, okay, and then you call it constructor student. Okay. Once you've declared an object of type student called s, to do its operations, let's say set name, you will do s.setName and so on. Okay, very, very straightforward. This one you already know. Okay. Now at this point, first activity break. Okay, I would like all of you to take a look at your, let me see, present programs. I would like all of you to take a look at your activities. Okay, so what I want you to do is, okay, first, please do your question 1, write the Java code for the car class, okay, along with question 2, draw the class domain diagram based on Java code below. Okay, so if you remember a class domain diagram, it means that you need to have your attributes, but the attribute types are not required. Alright, although if you want to put in the attribute types, that's fine as well. Okay, in fact, let me think. Yeah, okay, do your class domain diagram with the attribute types, and let's do a class design diagram. Is that alright? Okay, everyone's alright? So okay, LL is out, so let me put him back in. It's strange that people randomly getting kicked out or accidentally getting kicked out. Okay, so to repeat, right, I would like all of you to do your activity 1, which includes questions 1 and 2. Okay, when I say do, right, for question 1 it's pretty easy. You want to you can type in your answer, right, save it as a document, you can put it as a conversation into Skype, right? For question 2, please just scribble it on a piece of paper somewhere, right, and then I will review it later on. Okay, so I'll give all of you maybe 10 minutes to do this, and then I will continue the presentation after this. Okay, I will stop the recording now. Okay, so that's so to reduce the size of the YouTube outlook. Okay, go ahead.